Now, this is the last example of operational amplifier usage in practice, and this is how to get an independent current source by using the operational amplifier. As we know that independent current source, we said the voltage sources, independent voltage sources, whether they are DC or AC, the very common energy sources, power sources that we use in practice. DC voltage, independent voltage sources are the batteries, which are very common in our everyday life. And the other one is the AC independent voltage source, and which is available in the circuits. All the equipments run by this energy source or the power source. But independent current sources are not that much common in our daily life. But we could get that independent current source in practice by an electronic circuit, and this circuit is that circuit. While analyzing this circuit, we are saying this circuit here in that dot square in is independent current source. So we are going to show that this is an independent current source. What does this mean? Whatever you connect to this element current does not change. It is independent from the element which is connected to it. The current is independent from this element. So whether you collected RL equal 50 ohm or 100 ohm or 1000 ohm, this circuit independent current course gives you the same current to that. Current does not change, but the voltage is determined by this load resistance value, of course, which is the multiplication of IL with the RL. So let's prove that whether that IL is independent from that RL. So the only material that we are going to use is the definition relation of this ideal operation amplifier. Let me move this a bit further and write the definition relation of this operation amplifier here. Just remind you, Vp minus Vn is almost equal to 0. Ip equal In is equal almost 0. So that these are the node voltages. Remind you once more. And this difference equal to 0 means the voltage, this terminal voltage difference is equal to 0. That means short circuited. And that is ground. So that means Vp between this voltage. Vp is the voltage between this node and ground, and Vn is the voltage between this node or this node and the ground. That means Va voltage is the same as Vn. Now if you use the definition here, it says Ip current is equal to 0. That Ip current is equal to 0. That means that current is 0. That current is the same as this resistor's current. If you multiply this resistor's current with Rs, you get the voltage of the resistor, which is 0, isn't it? If this current is 0, 0 times Rs gives you 0. That means the voltage is 0. Since this voltage is 0, so this is Rs voltage becomes this voltage. And this voltage difference is 0 short circuit, so Rs comes to here. So this point or this node voltage is equal to Vs. Then the current here that we're going to see here, that current, let's say IRA is equal Vs over Ra. On the other hand, if In equal to 0, we are saying IN equal to 0, that means this current is 0. If this current is 0, if you write a Kirchhoff current law equation for this node, since this current is 0, this current is going to be the same the IL. So IRA is equal IL. So that means this load. Conclusion, IL is equal Vs over Ra. So if you look at here, this is independent source, Ra this resistance value, and current here is this load current. So load current does not depend on the RL. So it is independent current source. We are saying whatever the RL value is, my current is Vs over Ra, those two does not change. So that means IL becomes independent from the RL load. Therefore, it is called independent current source. So we can show now this circuit, which is in the dot square, as an independent source like that, of which current is Vs over Ra. So by choosing the right Ra value, you can arrange the independent current source current value by choosing the Ra value. So this is a good example of the usage of operational amplifier in practice. So that's the end of this video.